A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Hey everyone, welcome back to my weird prompts. I am Korn, and I am sitting here in our living room in Jerusalem with my brother. It is a beautiful afternoon here, and we have a topic today that is truly the bedrock of everything we do on this show, even if we do not always realize it.
Herman Poppleberry here, and I am ready to dive deep into the weeds. We have a really fascinating prompt today that our housemate Daniel sent over. It is one of those topics that sits right under the surface of every conversation, every song, and every whispered secret, yet most people rarely think about the technical architecture behind it. We're talking about the International Phonetic Alphabet, or the IPA.
And just to be clear for the listeners, Herman, we are not talking about the beer. I know you enjoy a good craft brew, but we are focused on linguistics today.
I would never dream of confusing the two, Korn, though both involve a certain level of complexity. While an India Pale Ale involves sensory data for the palate, we are focused on the sensory data of human speech. This is something I've been wanting to talk about for a long time because the IPA is essentially the source code for how we communicate. It is the universal map for the human vocal tract.
It really is. You know, I was thinking about this earlier, and the best way to frame the problem the IPA solves is to look at what linguists often call the Tower of Babel problem. It is not just that we speak different languages, it is that the way we write those languages down is often a total disaster. Orthography, or the conventional spelling system of a language, is frequently a terrible representation of how people actually talk.
Spelling is often a historical accident. It is a snapshot of how a language sounded hundreds of years ago, frozen in time while the actual spoken language continued to evolve. English is perhaps the most famous offender. We have that classic linguistic joke about the word goatee, spelled G-H-O-T-I. If you follow the inconsistent rules of English spelling, you could argue that goatee should be pronounced like the word fish. You take the GH from the end of the word tough, the O from the word women, and the TI from the word nation. Suddenly, fish is spelled G-H-O-T-I.
It is absurd when you lay it out like that, and it highlights why we need a standardized system. If a scientist wants to study a chemical compound, they use a periodic table where every symbol is unambiguous. If a musician wants to share a melody, they use a staff and notes that mean the same thing to a pianist in Tokyo as they do to a cellist in Berlin. But for the longest time, we did not have that for the most fundamental human tool, speech.
That is where the International Phonetic Alphabet comes in. It was first published back in 1888 by the International Phonetic Association, led by Paul Passy. The goal was to create a system where one symbol equals exactly one sound every single time with zero exceptions. It was designed to be a universal framework that does not care if you are speaking English, Hebrew, Swahili, or a rare dialect in the Amazon rainforest.
I think it is important to define what we mean by a sound here because Daniel's prompt specifically asks about phonemes. Herman, for the folks at home who might be getting flashbacks to high school English class, can you break down the difference between a phone and a phoneme?
This is a crucial distinction. A phone is the actual physical sound that comes out of your mouth. It is a measurable acoustic event. A phoneme, on the other hand, is an abstract mental category. It is the smallest unit of sound that can change the meaning of a word in a specific language.
Right, like the difference between the words pat and bat. In English, the P sound and the B sound are different phonemes because switching them changes the word.
Precisely. But here is where it gets tricky. Think about the letter T in the words top and stop. If you hold your hand in front of your mouth when you say top, you will feel a little puff of air. We call that aspiration. But when you say stop, that puff of air is usually missing. Physically, those are two different sounds or two different phones. But in the English-speaking brain, they both belong to the same phoneme category of T. We do not have any words where the only difference is that puff of air. However, in a language like Thai or Hindi, that puff of air is a phoneme. It changes the meaning of the word.
So, the IPA has to be able to handle both the abstract categories and the physical reality.
It does. Linguists use what they call broad transcription, which uses slashes and focuses only on the phonemes, and narrow transcription, which uses square brackets and all these little marks called diacritics to show exactly how the sound was physically produced. It is the difference between a high-level summary and a high-resolution photograph of a sound.
Let's get into the numbers Daniel asked for. When we look across all known world languages, how many distinct phonemes are we actually talking about? In English, we have 26 letters, but we have about 44 phonemes, right?
That is correct for standard American English. But globally, the number is much larger, though perhaps more manageable than people might guess. Most linguists agree that across all known world languages there are roughly between 140 and 150 distinct phonemes. Now, I should clarify that this number is a bit of a moving target. If you count every possible minute variation and every rare click or whistle, some databases like the UCLA Phonological Segment Inventory Database might list hundreds of unique segments. But in terms of the core building blocks used to distinguish meaning, 150 is the generally accepted ballpark.
150 sounds to build every word ever spoken by humanity. That feels surprisingly small given the infinite variety of human expression. It is like a universal Lego set with only 150 types of bricks.
It is small in one sense, but the way those sounds are combined is where the magic happens. What is really interesting is the distribution. Most languages are incredibly efficient. They tend to hover around 20 to 40 phonemes. You have outliers on both ends of the spectrum, though. On the low end, you have a language like Rotokas, spoken on Bougainville Island in Papua New Guinea. It is famous for having one of the smallest inventories in the world, with only about 6 to 12 phonemes depending on the analysis.
Only 12 sounds? That is incredible. Imagine trying to build a whole vocabulary with only 12 distinct sounds.
It leads to very long words and a lot of repetition, but it works perfectly for them. Then, on the other extreme, you have the Khoisan languages of southern Africa, like Tsu, which is also known as exots. These languages are famous for their complex click sounds. Tsu is believed to have one of the largest phoneme inventories in the world. Some estimates put it at over 160 distinct sounds. They use 5 different types of clicks combined with different voicings, nasalizations, and tones. To an untrained English speaker, it sounds like a rhythmic, percussive performance, but it is a highly structured, incredibly dense system of communication.
That is where the technical rigor of the IPA becomes a literal lifesaver for linguistic science. If a researcher from here in Jerusalem goes to southern Africa to document a language like Tsu, they cannot just use the Latin alphabet. They would be missing 80% of the information. They need those specific IPA symbols for dental clicks, lateral clicks, and alveolar clicks. Without that standardization, the data is useless to anyone else.
This brings us to the mechanism of the IPA. It is not just a random list of symbols, it is a biological map. When you look at an IPA chart, it is organized as a grid based on the physiology of speech. On one axis, you have the place of articulation, where in your mouth the sound is made. Is it at the lips, which we call bilabial? Is it the tongue against the teeth, or dental? Or is it way back at the glottis in your throat?
And on the other axis, you have the manner of articulation.
How is the air moving? Is it a plosive, where you completely block the air and then release it like a tiny explosion, like the sounds P or B? Is it a fricative, where you force air through a narrow channel to create friction, like S or F? Or is it a nasal, where the air goes out through your nose? By mapping these two coordinates, the IPA can describe almost any consonant a human can produce.
And then you have the vowels, which are mapped on that famous vowel trapezoid. I love that diagram because it literally represents the space inside your mouth. The vertical axis is how high your tongue is, and the horizontal axis is how far forward or back it is.
It is brilliant. It treats the mouth as a three-dimensional acoustic chamber. And the IPA does not stop at consonants and vowels. It has an entire system for suprasegmentals. These are the features that sit on top of the sounds, like stress, pitch, and duration. In English, stress is vital. Think about the word record, the noun, versus record, the verb. The only difference is which syllable you emphasize. In the IPA, we use a little vertical mark that looks like an apostrophe to show exactly where that stress falls.
And for tonal languages like Mandarin or Cantonese, the IPA has tone markers that show the pitch contour, whether the voice is rising, falling, or staying flat. It is a complete technical manual for the human voice.
This leads us to the one-to-one mapping principle, which is the genius of the system. In the IPA, a symbol always means the same thing. Take the English TH sound. In the word thin, it is unvoiced. Your vocal cords do not vibrate. In the word this, it is voiced. In standard English, we use the same two letters for both, but in the IPA, they are distinct. The unvoiced one is the Greek letter theta, and the voiced one is an eth, which looks like a crossed out D. There is no ambiguity. If you see the symbol, you know exactly how to position your tongue and whether to vibrate your vocal cords.
It removes the guesswork, and that is why it is so important for the preservation of minor or niche languages, which was the second part of Daniel's prompt. We are currently living through a period of massive linguistic loss. Some estimates suggest that a language dies every 2 weeks. When a language vanishes, we lose a unique way of categorizing the world, a unique history, and a unique oral tradition.
It is a tragedy, but the IPA provides a way to mitigate that loss. When linguists work with the last remaining speakers of an endangered language, say, an indigenous language in the Pacific Northwest like Lushootseed or Tlingit, the IPA is their primary tool for documentation. They can create a permanent, scientifically accurate record of exactly how that language sounds.
I was reading a case study about this recently. In the Pacific Northwest, many of these languages have sounds that are incredibly difficult for English speakers to even hear, let alone reproduce. They have glottalized consonants and lateral fricatives that sound like a hiss on the side of the tongue. Without the IPA, a researcher might just write down a K or an L and call it a day. But that would be like trying to paint a sunset using only 3 colors. You lose all the nuance.
By using the IPA, they can create dictionaries and teaching materials that allow the next generation to reclaim their ancestral tongue with phonetic precision. It turns a spoken tradition into a technical record that can survive even if the last native speaker passes away. It is an act of digital and cultural preservation.
This actually reminds me of what we discussed back in episode 933, when we were looking at the high stakes of international interpretation. Those professionals who bridge the gap between world leaders at the UN or in diplomatic summits have to have an incredible grasp of phonetics. Even if they are not writing an IPA every day, their training in phonetic awareness is what allows them to catch the subtle nuances in a leader's speech. A slight shift in aspiration or a change in vowel length could signal a shift in meaning or even a hidden emotional state.
If you do not have a category for a sound in your brain, you often literally cannot hear it. It sounds like noise to you. Phonetic training, and the IPA specifically, gives you the categories. It expands your mental map of what is possible in human speech. It is like going from a box of 8 crayons to a box of 128. You can see, or rather hear, the world in much higher fidelity.
Let's talk about the second-order effects here, specifically in technology. We are living in a world of voice assistants, real-time translation, and AI that can mimic anyone's voice. How does the IPA fit into the world of artificial intelligence?
This is where it gets really technical. If you are building a text-to-speech system, or TTS, you have to tell the computer how to turn written characters into audio waveforms. As we established with the Goethe example, you cannot just give the computer the alphabet. It would be hopelessly confused by the inconsistencies of English or French spelling. So, most modern speech synthesis systems use a phonetic intermediate layer.
So, when I ask my phone for the weather, the AI is not just looking at the words, it is converting them into a phonetic string first.
Precisely. It takes the written word, looks up the phonetic transcription in a massive database, and then uses that to generate the audio. In the early days of computational linguistics, researchers developed something called the alphabet. This was a system created in the 1970s to represent IPA symbols using standard ASCII keyboard characters because computers back then couldn't handle the special IPA symbols.
So the alphabet was like a simplified, computer-friendly version of the IPA.
Instead of using the theta symbol for TH, they might use the letters TH in a specific code. But the underlying logic was pure IPA. Today, with Unicode, computers can handle the actual IPA symbols, but that phonetic layer remains essential. If you want a machine to speak naturally, it needs to know the exact phonemes, the duration of the sounds, and the stress patterns. All of that is captured in the IPA framework. It is the data structure for human speech.
And it works the other way too for speech recognition. When I talk to my phone, it is looking for the acoustic signature of specific phonetic features. It is listening for the hiss of a fricative or the silence followed by a burst of a plosive. By using a standardized system like the IPA, researchers can share datasets across different languages. They can train a model on the sounds of English and then fine-tune it for Hebrew or Arabic, because the underlying phonetic categories are standardized.
It is a universal language for machines to understand human speech. And I think there is a deeper point here about objectivity. In a world that is often divided by national identity and culture, the IPA is refreshingly descriptive rather than prescriptive. It does not tell you how you should talk, it just gives us a way to describe how you do talk.
That is an important distinction. Often, when we talk about standardizing language, it feels like an attempt to erase local dialects or force everyone into one box. But the IPA is the opposite. It is a tool that actually helps protect local identity. By documenting a regional accent or a minority language with phonetic precision, you are giving it a permanent place in the record. You are saying that this specific way of speaking has value and deserves to be understood on its own terms.
It is about respect for the reality of human variety. Instead of forcing everyone into one box, we created a system that has a box for everyone. I think that is a very powerful concept. It is standardized, yes, but it is a standard that celebrates diversity rather than suppressing it.
So, Herman, if a listener wants to actually use this, where do they start? Because if you look at a full IPA chart for the first time, it is incredibly intimidating. It looks like a page of ancient runes or complex math equations.
It definitely does. My advice is to start small. Do not try to memorize the whole chart. Start by looking up the IPA transcription of your own name. It is a great exercise because it forces you to really listen to how you say it. You might realize that you are using sounds you did not even know existed in your own name. For example, if your name is Burton, do you actually pronounce the T, or do you use a glottal stop, that little catch in the throat?
That is a fun one. My name, Corn, is pretty simple phonetically, but even then, the way I pronounce that OR combination is very specific to my accent. If I looked it up, I would see exactly which vowel symbol represents my specific sound.
And then move on to common words that are spelled strangely. Look up the word through, though, and thought. See how the IPA handles those different endings. There are some great interactive IPA charts online where you can click on a symbol and hear the sound. It turns the abstract symbols into something tangible.
I think one of the biggest takeaways for me is how the IPA strips away the bias of our own native writing system. We grow up thinking that the letters we use are the natural way to represent sound. But the IPA reminds us that our alphabet is just a convention, and often a messy one. The reality of speech is much richer and more complex than 26 letters can ever capture.
It is a humbling realization. It makes you realize that every time you speak, you are performing a complex physical feat that has been mapped and studied by generations of brilliant minds. The IPA is a testament to our desire to understand ourselves and to bridge the gaps between us. This connects perfectly to what we talked about in episode 1045 regarding the polyglot mind. Those super translators and hyperpolyglots often use the IPA as a shortcut. Instead of guessing at the pronunciation of a new word in a foreign language, they look at the phonetic transcription. They know exactly where to put their tongue and how to shape their mouth. It takes the guesswork out of language acquisition.
It is like having the sheet music for a song instead of trying to play it by ear. You can see the notes.
That is a perfect analogy. The IPA is the musical notation for the human voice. And just like music, speech is a physical act. It involves muscles, breath, and resonance. The IPA is the technical manual for that physical performance.
I think that is a great place to wrap up the core discussion. But before we go, I want to touch on the future. We are seeing AI getting better and better at mimicking human speech. Do you think we will eventually reach a point where we do not need the IPA anymore? Where the machines just learn the sounds directly from audio without needing the phonetic layer?
That is a great question. We are already seeing some of that with end-to-end deep learning models. They can go straight from text to audio. But I would argue that we will always need the IPA for the same reason we still need math even though we have calculators. We need a human-readable, standardized way to verify and analyze what the machines are doing. If a model develops a weird glitch in its pronunciation, we need the IPA to describe and fix that glitch. It is the language of debugging for speech.
Plus, for the purpose of scientific study and language preservation, we cannot just rely on a black box AI model. We need the transparent, objective records that the IPA provides. A machine might be able to mimic a dying language, but the IPA allows us to understand its structure. Understanding is the goal, not just imitation.
The IPA is a tool for human understanding. It is one of those silent pillars of modern civilization. Without it, our understanding of human communication would be decades behind where it is now.
Well, this has been a deep dive. I hope everyone listening feels a little more connected to the sounds coming out of their own mouths today. It is a fascinating world once you start looking at the source code.
It really is. And if you found this interesting, I highly recommend checking out some of our related episodes. Episode 933 on interpretation is a great companion to this, as is episode 1035 on the polyglot mind. They all touch on this central theme of how we bridge the linguistic gaps between us.
And hey, if you are enjoying my weird prompts, we would really appreciate it if you could leave us a quick review on Spotify or whatever podcast app you are using. It genuinely helps other people find the show and keeps us going.
Yeah, it makes a huge difference. We love seeing the feedback and knowing that people are digging into these topics with us.
You can find all our past episodes, including the ones we mentioned today, at our website, myweirdprompts.com. We have a full archive there, and you can even send us your own prompts through the contact form.
Maybe your prompt will be the one we dive into next week.
Thanks for listening to My Weird Prompts. We will see you next time.
Until next time.
I have to say, Herman, I am still thinking about that goatee thing. I am never going to look at the word fish the same way again.
It is a curse, Corn. Once you see the phonetic reality, the spelling of English just looks like a series of unfortunate accidents.
It really does. But at least we have a map to navigate the chaos.
The IPA is the compass.
All right, let's go see if Daniel has any more brain teasers for us.
I am sure he does. He has always got something interesting brewing.
Take care, everyone.
Bye for now.
You know, I was just thinking, we should have mentioned the vowel trapezoid in even more detail. The way it maps the physical space of the mouth is so cool.
Oh, the way it represents the tongue position? Yeah, that is a classic. Maybe we can cover that in a follow-up. We could do a whole episode just on vowels and the history of the cardinal vowels developed by Daniel Jones.
Let's not get ahead of ourselves. I think people's brains are full enough for one day. 150 phonemes is a lot to process.
Fair enough. One phoneme at a time.
All right, really signing off this time.
Goodbye.
So, Herman, I was looking at the IPA chart while you were talking, and I noticed the section on suprasegmentals again. We didn't really get into the specifics of length marks.
Oh, absolutely. The IPA uses those two triangles that look like a colon to show a long vowel. In some languages, like Finnish or Japanese, the length of a vowel completely changes the meaning. It is just another layer of precision that the standard alphabet misses.
It is amazing how much information we pack into such a short burst of air. It is not just the sounds themselves, it is the rhythm and the melody.
It really is. And the IPA captures that rhythm. It is what makes speech sound human rather than robotic. Although, as we discussed, the robots are getting better at that precisely because they are using these phonetic frameworks.
It really highlights the technical rigor that went into creating this. They had to think about every possible way a human could vary their voice and find a way to symbolize it. It is a massive intellectual achievement that we just take for granted.
It really is. It is a silent pillar of the modern world.
Well, I think we have truly exhausted the topic for today. I am going to go practice my alveolar trills.
Good luck with that. It takes some practice to get the tongue vibrating just right against the alveolar ridge.
I will get there. See you later, Herman.
See you, Corn.
And thanks again to Daniel for the prompt. It was a good one.
Definitely. Keep them coming, Daniel.
All right, for real this time. Goodbye, everyone.
Bye.
One last thing, Herman. Did you know the IPA also has symbols for things like whispering or speaking with a nasal voice?
Yes, those are part of the extended IPA, often used by speech therapists and clinicians. It can describe disordered speech or very specific vocal qualities. It really does cover everything.
Incredible. Okay, now I am done.
Me too. Let's go.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show. My weird prompts